Hi, my name is Gopal. I work at Microsoft and I'm a speech and hearing scientist. I'm standing outside the anechoic chamber, which is the world's quietest place. I'd like to invite you to a journey inside the anechoic chamber, where sounds are very different. This is an anechoic chamber. By anechoic chamber, we mean no echoes. So every sound that's made here, like when I'm talking, gets absorbed by these wedges. Take a look around. These are the wedges, and see how the wedges line all of the walls, including the ceiling, as well as the floor. So I don't have a real floor anymore. I don't have a solid surface of flooring. What I have is steel cables that serve as flooring for me. And these are the same steel cables that are used to stop aircrafts and aircraft carriers. Give you an illustration of how sound is absorbed. When I'm talking to you, you get to hear my speech directly. My direct speech is aimed at you. As I rotate, you'll get to see my speech change quite a bit when I go full circle. I'll do that again. My speech is directly coming to you now. As I turn around, much of my direct speech is absorbed by the wedges. What you hear is sounds leaking from around the head and coming to you. Okay? So one more quick run. Here is when I'm talking. As I turn around, you'll get to hear the difference between direct versus how much of it is absorbed. 99.999% of the sounds are absorbed by these wedges. Low frequencies get trapped in here by bouncing back and forth. High frequencies are completely absorbed by the wedges. These chambers are extremely valuable when we develop anything in audio technologies. From measuring Xbox's console fan noise, for example, or the components in a surface, some of the components make sounds very low level, but they are there. We measure them in this clean environment, which is the purest form of recording without being interference from the walls or from the outside. So we better our products for audio performance. Anything to do with audio where we have microphones, loudspeakers to measure distortions of a surface, products, our consoles. These kinds of chambers become very extremely important for us. There's a second big feature of this chamber. That is how much sound it attenuates from the outside to the inside. How much sound is killed by building this barrier. What I'm going to do is open the door and let you hear what our engineers are doing on the outside. They're listening to loud music while working. And I'm going to close the door. Should be a dramatic drop. I'm going to do that again so you get to hear it. So these walls and the wall outside of this chamber, the concrete wall we have, attenuates about 110 dB of sound. That's a lot of sound that it cuts out, and that's by design. These are the two critical features of our chambers: no echoes and massive attenuation from outside to inside. Therefore, everything we measure here is sound in its purest and the quietest form. We can measure very, very, very low level sounds, and we measure sounds without interference from the walls. These are absorbed. When we develop a HoloLens, these kinds of chambers are very important to see how human beings spatialize sounds. How do we know a sound is coming from the right or the left or from top or bottom? We want no reflections. We will have multiple speakers here. We'll put two microphones around the ears. We find the difference between the right ear pickup and the left ear pickup. The human brain is very attuned to picking up very small differences between right ear and left ear. Compare the two and saying, oh, this is why the sound is coming from the right side or the left side or from top and bottom. So these kinds of chambers become extremely invaluable for us to develop this 3D audio rendering capabilities. I am going to step outside the chamber now, and you get to experience what silence really is about. I hope you enjoy it. Thank you.